So we start an example with two members connected at a pin being pulled by 60 pounds, and this is the angle that these two members in the directions they make with respect to this 600-pound load. And first I drew the 600-pound line, then I put a reference line in here associated with this guy, and that's going to be our first member, because our second member here has to cross and also touch this point. So it has to come in like this. So we have one red vector this way, one component represented as red vector in that direction. Then I saw that we had this angle here that I reproduced over here is 30 degrees, and we know that this is 30 degrees. This has to be 30 degrees. And then I looked over here, and we've got 60 degrees, 30 and 30 is 60, between this line, green line, and the purple line. So if that's 60, the rest of this to make 180 degrees is 120. So 120 plus 30 is 150, so we have 30 left over for 30. And you can find this in another way. So now the trick is to figure out what these are in the book. They call these, this one was called FU, I think. Yeah, this one was FU. No, this one is FV, because I've got things reversed, and this one is FU. So looking this over, I see that I have 600 pounds, and I have an angle opposite this, that screaming law of sines, and I have an angle here, and I don't know what this is, so definitely law of sines. So let's do that. So we'll say that FU equals, well, FU over the sine of 120 degrees equals 600 over this 30 sine of 30 degrees. Now you work this out, you'll get 1,039 pounds. Okay, let's get the FV handled. FV, so this is over sine of 30. We can do either one of these since we have them, but it's probably best not to use the one we just calculated. So over 600 over sine of 30 degrees. Well, look at that. Makes life easy for us. These cancel. And FV equals 600 pounds. Probably should have added that this is where our solution is. So we got a given, we got to find, and a solution. Okay, so you have a barge being pulled by two boats. If the resultant is 5,000 pounds horizontal here, then what's the tension in the ropes? Well, let's make a diagram here. So let's pull this out, put it over here. So that's our horizontal. £5,000-pounder, and that's where it's pinned at B. And let's just go in some directions. Let's go A's direction. I'll move this diagram a little bit. So I'm going to copy it but you don't have to have it copied exactly. So this is the line of action in this direction. And then this is our line of action in this direction. That's where they cross. Remember, you got to end up here. So this has to end here. This has to end here. And we can start throwing in some angles. 30 degrees here. If we're going to write 5,000 pounds, we got to put it in a useful spot. So this is 5,000. And we can put the units in. Okay, so this is given as 45 degrees. If that's the case, that means this is 45 degrees. If that's 45 degrees, this must be 105 degrees. And again, we have a lost sign situation. So I'm going to label this as A and C to make life easy for us. So A over sine of 45 equals C over sine of 30 degrees. And that equals my choice, how I want to handle this, 5,000 over the sine of 105 degrees. All right, so work through that. Solve for A or C. And you'll end up with A equals 2588 pounds and B equals 3660 pounds. All right. Okay, so if we define alpha as this angle 45, and we want to find that, we want to make alpha so that the tension in this rope on this boat is the smallest possible. That way, maybe this boat has the weaker link and we just want to try to reduce the chance of it breaking. Then let's calculate how to make that happen. So again, this is 5,000. And let's draw our lines on the other side now. So first I'll stick in the line of action associated with the A boat. And not really concerned about the length. And now for the B boat, in order to make this as small as possible, what we do is we start here and we see that's long. That's long. The smallest occurs when what? This is 90 degrees. So let's work that out then. First off, we've had this is a given as 30 degrees, this angle here. Well, if that's 30 degrees, this has to be 30 degrees then, because these two lines are parallel. Which puts this at 60 degrees if we wanted to use it. But we don't even need that, do we? Because we have this and we have this angle, and we know this is opposite over hypotenuse. So if we called this C, I guess, C over 5,000 equals sine of 30 degrees. So C now equals 2,500 pounds. And we called it B up here, but it really is, this is C here, 2. It's this guy here. Should have a vector head on him. So it went down from that, and we can also calculate A. And if you calculate A, this guy goes from here to here. A turns out, and you can do that on your own. That's adjacent over hypotenuse equals cosine of 30. So A over 5,000 equals cosine of 30 degrees. A is going to pick up extra load now because we're going to shed it onto him from C. And so he goes up from 2588 to 4330. And there are two example problems.